A block of 20 kg mass is pulled horizontally by a force of 10 Newton along a frictionless floor. By frictionless, it simply means maybe there's oil on the floor or whatever it is that reduces friction, that causes friction not to be there. So they say, what is the acceleration of the body? Okay. Remember I told you that whenever you are asked a question that has to do with movement of an object and you see force there, that means it's dynamics. And dynamics simply, I know they will define it for you as the study of motion with respect to the force causing it. But I want you to take it that dynamics simply means the study of forces, the study of forces that cause motion. So when you are not treating the motion aspect of it, you are referring to the kinematics. Now, when you are looking at the forces, you are looking at dynamics. So whenever it's dynamics, it simply means that, or whenever force is mentioned, it simply means that you need to look around and check for the forces around there. So notice that they just gave me one force acting on this, and it's one object. And assuming they didn't even give me, whenever I have just an object, or a body of mass that is in kg, they said this one is in 20 kg. Whenever I have a body of mass horizontally, remember we've treated vertically. Whenever a body is being acted on horizontally, if it's one body, there are two forces acting on it, the forward force and the frictional force. But once the frictional force is not mentioned, provided friction is not mentioned, a body act on a horizontal surface or moving in horizontal surface is being acted upon by just the forward force, which is action force. Assuming there are two bodies, the first body is being acted on by just the forward force, which is action force, while the second body is being acted on by the action force. And this force that acts on this first one, to it will be feeling the weight of this one, and it becomes tension to it. So it will be the forward force minus this tension, which is this. So for the second body, it will be F minus T. And all the forces of a system is equals to the mass of the system and the acceleration, the movement. So this one, the single one, will just be F equals to ME. So this is the dynamics of a body in horizontal space, or you say in horizontal floor, or you say observing horizontal acceleration. So let's try to solve this question. Since it's just one body and they say it's on a frictionless floor, so F will be equals to MA, mass of this, and the acceleration that the body would take. F will simply be equals to, this is 20, A I don't know, F is 10. So this means divide both sides by the coefficient of A. So you can very well see that this will cancel this. A is equals to 1 over 2. And 1 over 2 is something I'm saying 0.5 meter per second square. Thank you very much. Don't mention. Alright, let's move to the second question. The second question says, which is number 3. Number 1, deduce Newton's laws of motion and mechanics. I did not define it because we've already treated that. Go and check the first video on dynamics. Okay. Yes. Okay. Okay, but okay, see what we'll do. In order not to skip anything, let's start. The first law, Newton's first law. Newton's first law. This law states that a body at rest will remain at rest. And if in motion, will continue to move until acted upon, or say unless acted upon by an external force. So if a stone is thrown, you will see that that stone will continue to move till it hits something. That is it. So if you carry an object and keep, and you don't touch it, notice that what will happen is that that object will continue to be there unless someone moves it, or wind, or temperature, or certain things affect it and causes it to disintegrate or change its position. And like I normally tell my students jokingly, that this law was invented when there was no phone, because you very well know that if you happen to keep your phone and leave, it will not remain at rest. Something must happen to it. So you can see external force acted upon it. So that's the first law. So the second law, Newton's second law. And please, it is important to note that this first law is also called law of inertia. Law of inertia. Very important to note that. So let's look at the second law. The second law accounts for a good number of things we know in physics today. This second law states that the force applied to a body of mass is directly proportional to the rate of change of its momentum. So what this second law is trying to say is that if I have an object, if I apply force this way, this object will go this way. And if I apply force bringing it this way, the object will come this way. So that mathematically it can be represented as F directly proportional to change in momentum. And we know that momentum is mass times velocity, so all over time. So when you introduce F is equals to K is a proportionality constant, which is equals to 1. This is change. So where K equals to 1. And notice that this is the same thing as saying F is equals to mv minus mu. Velocity is represented with V capital and U as the final and initial, that is change. Notice that the mass is the same. Whenever you're talking about momentum, it's just one mass. If it involves two masses, that means you've started talking about collision of bodies or conservation of momentum. So all over T. And this can be the same thing as saying, this can also be written as mv minus u, because if you multiply it will be the same thing all over T. Now notice that v minus u over T is the same thing as acceleration. So if we replace this becomes F equals to ma all over T. And anything standing on this one is over 1. This can be the same thing as saying Ft is equals to ma. Are you seeing it? Okay, watch. I think we almost made a mistake. Remember we said v minus u over t is equals to a. That is change in velocity all over time. So this is supposed to be F equals to ma, not this. So there are two things that you can discover using this formula. I wanted to do the two at the same time. That's it. So F is equals to ma. A for everything here, then m. So you can have this formula like this, and this is the formula we all know. This is the popular formula. So F equals to ma. Now notice that from this point, this is mass, this is acceleration. Notice that from this point where I have F equals to mv minus mu all over t, I can actually cross multiply too. So this is equation 1. So I can actually cross multiply. So I get Ft equals to mv minus mu. This right here is what we call impulse. And we say that impulse is force, the product of force and time. The unit is Newton seconds. And notice that this force times time is equals to mv minus mu. So whenever they ask you to find impulse, you can find impulse by doing impulse equals to ft, or you can get impulse is represented with I by doing m into v minus u, depending on what the question gave you. So you need to know these two things. Since this is equals to this is also equals to this, which means that change in momentum can also be given Newton seconds as the unit. So notice everything about the first and second law. Has to do with just a body. It has to do with just one body, a kg, a mass. It has to do with just mass. It can be going up, it can be going down, but it has to do with just a mass. But from the third law, from Newton's third law of motion, which states that action and reaction are equal and opposite. And this law was stated as the force experienced by a body of mass is directly proportional and opposite to the force experienced by another as a result of the force applied by the second force, or you say the second object. So this is what it means. What it means is that if, for example, you see a wall, you carry your leg and come with speed, that wall is heavy, and hit on that wall. Notice that what will happen is that for some weeks you will not be able to walk. Why? Because the force you apply to that wall, it will feel the impact, then it will give you something in return. This is what naturally exists even in logical sense, when they tell you that if you want somebody to respond to you nicely, try to be nice. But the minute you get to a point where you attack their logical reasoning, they give you a feedback, which is the reaction. So this third law simply talks about two or more objects. So it's no longer when you look at just one object or one mass or 1 kg. So it simply means that if I happen to apply force to two or more objects, what happens? So what it means is that a situation, for example, in this case, if I apply a forward force here and I apply a forward force to this as well, notice that what will happen here is that this first object will experience force this way, and this forward force. And as it's experiencing this force, there will be, should I say, a part of it that tends to go back, that tends to want it to go back, and that is friction. But provided friction is not mentioned, so in this case we are still considering that we've not started looking at the friction. So provided friction is not mentioned, this forward one, we have what we call T1, because the force on a rope is known as tension. Now this second mass, so this one now, the force here will simply be T1 is equals to the mass of the object and the acceleration that it will go through. Now for the second object, let's say this is the second kg, it will experience this force, the forward force, which is in this case T2. Then as it's trying to go forward, this rope on it will also be dragging this one. And as it's dragging this one, the weight of this one will want to make it to stay back. So it will be experiencing two forces, which is T2 minus T1 equals to mass of this object and the acceleration. So anytime you are treating, or you see more than two objects, or more than one object, you need to employ a formula, and that formula comes from, even when you're going vertical, so far as it's more than two forces, more than two objects, you need to employ the approach of forward force, which we call action force minus backward force, which we call reaction force, is equals to MA. So what this thing means is total force. You know that F is equals to MA. So in this system, it's no longer force on just one. F is just when you use only F equals to is when it's one object. So it simply means total force of the system. Force of the system is equals to MA. So you need to know that. So as we progress, as we start solving calculations, you understand this better. All right, let's look at this, the third question. The third question says a block of 20 kg mass is pulled with a force of 10 Newton at an angle of 30 degrees with the horizontal. Find the acceleration. So another thing you need to note about force, question 3, is if I have it this way, if it's one object, I'll just use F equals to MA. If I have it to be like two objects, the first one will still be F equals to MA, but the second object will be F for it. That is maybe the forward force, that is the action force minus the reaction force equals to MA. Then when I have an object and it is being pulled at an angle, let's say it is being towed at an angle. For example, a car now, when you are towing a car, you have it this way, this way, this way. Then another one that is pulling it will be inclined and is trying to drag it. So this particular car, this one now, the force that it will be experiencing is simply force on it and the angle created. So force at an angle. So whenever you hear it is inclined, if a body is pulled or a force is applied to a body at an angle, it becomes the force applied to an angle to the horizontal. You know that x-axis we normally say make use of cos theta. Cos theta is equals to MA. The force applied at an angle theta is equals to MA. So that means that this number 3, I'll simply say they gave me 20 kg mass pulled with a force of 10 Newton at an angle of, so 20 kg, 20, wait, let me write it, M equals to 20 kg, F equals to 10 Newton. The angle is theta is equals to 30 degrees. So making use of the formula, I will simply have F cos theta equals to MA. So 10 cos 30. This is 30. So 10 cos 30 is equals to 20. Then the acceleration is what they are asking us to find, 20A. And I don't know it, so I will divide both sides by 20. This will cancel this. This will cancel this. So you see that this can take care of this. So let's do it. Let's do 1 times cos 30 is the same thing as cos 30 divided by 2. So if you do the proper arithmetics, you are going to get that A is equals to 0.433. And remember, it's in meter per second square. We've done kinematics. Let's move to the third question. Or is it the fourth question? The fourth question. So they said the masses M1, M2, and M3 are connected as shown in figure 4.1. This is figure 4.1. M1 and M2 are pulled by the weight M3 hanging over a smooth pulley. The rope, which is not extendable, and the pulley has negligible mass. Find the acceleration A of the system. Okay. The pulley has negligible mass. Oh yeah. First, we analyzed it here. Force on an object, any object, every object has the gravity force acting on it downwards and normal reaction acting on it also upwards. And when rope is pulling it, notice that the force this way and the one this way, the two will be cancelled. So the net force vertically will be 0. when something is going up, another one is going down, net force is 0, so it will stay balanced there. But there's a force going horizontally. The first one, I told you, when you have just an object, the first one becomes F equals to MA, but in this case it's T1. T1 equals to MA. So the second object will experience the forward force and the backward force from this force that is pushing it, which is what we did here. And then the third object, and remember that the forward force that this one is experiencing is the forward force here by this one. So that is why when it comes to the third object, it will not be a backward force for it. Then let's analyze this. This is what we are given, and we are asked to find the acceleration. So for the first force, it will have, the first one, we have F equals to M1 times the acceleration. This pulley, because as this thing is trying to, the weight here will try to be pulling this thing, and gradually they will fall off. They will fall off this cliff, or you see, yes, this smooth pulley. So M1A. Why this second one will simply have the forward force, this force acting here. I don't want to put anything that will confuse it. This force acting as is dragging it, that is the force going forward, and then the one acting backward. So the second one will be, that is the second box, the F here, but I'm going to use T1. Force acting on a rope is tension, T1. So for this one, is going to be forward force, is going to be T2, the forward force, minus the backward force, T1. When it's going forward, it will be this one, the weight of this will be dragging it back. So equals to M2A. Now this one now, the force that is acting on this one forward is gravity. Gravity is what is acting on it forward. So that gravity that is acting on it forward, or you say weight. Yes, what is acting on it forward here is weight, which is, I can choose to use mg. So acting this way is weight, and we know that the weight, his weight is what is pulling it. Weight is equals to mg, and the m here, the mass here is 3. That is the third mass. So I have m3g weight minus this one's force. As it's trying to go forward, this one will be exerting tension that wants it to go back. So minus T2 minus T1 equals to M3A. So equals to M3, and the acceleration that it will go through, the acceleration, M3A. Okay. So if I know this, all right. So see, notice that what I did here. Notice that what I did here. Notice that this force, as it's going this way, the one dragging it back, the weight dragging it back is the weight of this one. And remember that the weight of this one, this particular thing here, is, notice that everything here is the same thing as what is here, and is equals to this. So I can simply say, let's replace the whole of this with what is equals to, which is M2A. You see it is equals to M3A. Then M3G. That is the force, the weight there. The weight is what is dragging it down, and it's M3G. Weight is mg. So the m there is 3, the third mass, g minus. So you see that if I know this, what this thing means now is that I can simplify such that what am I trying to get is this A, the acceleration of the system. The acceleration of the system is simply the final acceleration. It's still this A, this same A, final acceleration. That's what I'm trying to get. So I think what we can do here is to say, let's factor out the A. So how I can do it is to say, let this go here. So this will be M3G equals to M3A. As this one is crossing over, it becomes plus M2A. The acceleration of the system is what we are looking for. So this is going to be the same thing as saying A out, M3 plus M2. We've gotten what we are looking for. M3G is equals to this. So I can say, to make A subject of the formula, divide both sides by the coefficient, which is M3 plus M2, all over M3 plus M2. Are you seeing it? So you can see that this will be the same thing as saying, this is the same thing as saying, let's look well. Okay. So this is something as saying, let this divide this. So I have A is equals to M3G all over M3 plus M2. So, but notice that this is for, this thing now is more like comparing mass of the system for, that is acceleration of, this acceleration is for the second and third mass. Notice that the M I'm seeing here is M2 for the second mass, the third mass. So let's try to look at when we are carrying the whole system along. So what it simply means is that we will come here. Notice that T1 is equals to M1A, Shebi. T2 is equals to M2A. And notice that right here, okay, let's do it here. Since T1 is equals to M1A and T2 is equals to M2, sorry, yes, T2, if you make T2 subject of the formula, it will be M2A plus T1. That is C, this here. If you try to make this crossover, it will become plus T1 plus T1. So T2 is the same thing as saying M2A plus M1A. Are you seeing it? Which means that for T3 now, which is equals to, remember that T3 is the same thing as M3G. So, which is equals to M3G, that is weight. It's not tension there, but weight. So M3G. Notice that is minus T2 minus T1. So let's say we want to make it subject of the formula. If it's cross, it will now become equals to M3A plus T2 plus T1. And notice that T2 and T1, T2 has M2A plus M1A, and that M1A is for T1. So let's replace it, M1A plus M2A plus M3, sorry, A. So if we want to make A subject of the formula here, we can say A out, so that we have M3 plus M2 plus M1. So M3G. So you see that if we want to get the total mass of this, the total acceleration, the acceleration of the system for the whole system, you will now have, let me write this. You will now have M3G is equals to A M3 plus M2 plus M1. Divide both sides by M3 plus M2 plus M1. So this is simply going to be A is equals to M3G all over M3 plus M2 plus M1. Very simple. So see, the misconception there is, why I did it these two ways, simply to show you something. whenever you are doing this kind of question, this can only be affected by the backward force. It has no business with this. So the force acting on the third block is simply M3G. That is the weight minus the backward force, which is coming from this. As it's going forward, the weights, then the backward force. When it's talking about this becomes backward force. The forward force of the second one becomes its backward force. So minus T2 is equals to M3A. That's the mass and the acceleration. So you can only have forward and backward force. You cannot have backward force 2 times. That's what I'm trying to say. So forward minus backward force. That's what you're supposed to get here. So assuming you did this thing this way, such that if you get for this one now, M2 is simply M2A. Now for T2 minus T1 is equals to M2A. When you make it such a formula, it becomes this one is equals to M1A. So what I'm trying to say is, if you are used to, because we did this argument in class, that's why I had to show it here. Whenever you're talking about force on a body of mass, in the horizontal axis, horizontally, it can only be forward minus backward force equals to MA. So always use this approach. Get the forces. When you finish, you don't get the total force of the system, which is what we did here. We treated here. So we did T1. It has no backward force. The only backward force it can have is friction, and they did not specify about friction here. Then T2 is simply the forward force minus the backward force, and when you make T2 subject of the formula, it becomes this. Then for the T3, which weight is what is acting there, not tension, is going to be forward force minus its backward force. And when you do it minus its backward force, you will see that its backward force is equals to everything here, T2, and T2 is equals to M2A and M1A. That is why I brought this thing down here. You see it? So if you do it well, you don't get your answer. So T3 or M3, what I'm saying is that M3G is simply minus T2 equals to M3A. That's what I'm trying to say. So because T2 is already equals to T1 inside it, that is why we have all those formulas. So, but whichever way you do it, but you just need to get the concept that it just has to do with forward and backward. Equals forward minus backward equals to MA. So this is your answer. All right, let's go to the next question. A body of mass 4 kg undergoes constant horizontal acceleration of 3 meters per second. Calculate the resultant horizontal force acting on the body. What will be the resultant force on the body when it moves with a uniform velocity of 6 meters per second? Always pay attention to when a question asks you uniform velocity, because at uniform velocity, acceleration is 0. Remember I told you, that is question 5. Remember I told you, always look at velocity, acceleration this way. Deceleration this way. Then constant speed, or you say uniform speed, this way. And this uniform speed is the same thing as velocity, except when it's specified that is maybe the change direction. Speed and velocity are the same thing, but just that velocity has direction. So see that at constant speed or uniform velocity, there is no acceleration. It did not go up, it did not come down. So that means that acceleration is 0. A is equals to 0. So for that reason, let's look at the question again. A body of mass 4 kg mass, constant acceleration 3 meters per second square. Resultant force, we don't know it, that's what we are looking for, but force is equals to MA, and it's just one body. What will be the resultant force of the body when it's okay? Calculate the resultant horizontal force acting on the body. So it's going to be F equals to 4 times 3. F is equals to 12 Newton. Now they tell us again, calculate the force on the body when it moves with a uniform velocity of 6 meters per second. So at uniform velocity, we say m, which is 4, times 0. At uniform velocity, acceleration is equals to 0. So F is equals to 4 times 0. Anything times 0 is 0. F is equals to 0. So this is our answer to that question. Let's move to the next one. A car of mass 500 kg. A car of mass 500 kg. A car of mass 500 kg. Moving with, number 6, 500 kg. Moving with a forward acceleration of 6 meters per second square, is acted upon by a constant resistive force. That is resistance, opposing force. Anytime you hear opposing force, it means friction. Opposing force, Fr, equals to 800 Newton. Now they say calculate the force, which is force is always forward force. Or we say that force is any action that causes a body to accelerate. Any action that causes a body to accelerate or to move forward is called force. But any action that causes a body to decelerate or to move in backward direction is called friction. Or you say it's the limiting action. So they say we should calculate the normal force, which we don't know. They say we should calculate it. So they say calculate the force exerted from the engine to maintain this forward acceleration. All right, let's get to business. So since I see that there are two forces involved, I'll simply say this is frictional force. I'll always remember that in this case, assuming they say a force, the force of a body acts this way, they did not say it's opposing. I'll simply add up the whole forces. But since they said it's in different direction, resistive force, I'll simply do forward force, action force, minus resistive force is equals to the mass of the system and the acceleration, the movement of the body. So this is going to be F, which I don't know, minus 800, that is limiting friction, is equals to the mass is 500. Then the acceleration is 6. So notice that by the time you do this properly, 500 times 6 is around 3,000. Yes. Yes. Okay. F minus 800. So making F subject of the formula means that this will cross over, so that F will be equals to, add 800 to both sides. F will be equals to 3,000 plus 800, which gives us that F is equals to 3,800 in Newton. So this will be my final answer. So let's move to the next question. So this one says a body of mass 6 kg with a speed, or you say with a velocity, whichever way, always see it as the same thing, of 20 meters per second, is suddenly hit by another body moving in the same direction. That means the body that hits it, the body that hits it from behind, because for it to be moving in the same direction, it means it's from behind. Assuming it says that it hits it by another body moving in different direction, you know it's from the front. So if he hits it and it's the same, it means it's the same direction. It's suddenly hit by another body moving in the same direction, so it's from behind, thereby changing the speed of the former body to 50 meters per second. It's just indirectly telling you the new velocity. So which is the final velocity? 50 meters per second. Then I ask us, what is the impulse? What is the impulse of the first body, of the body that experienced 20 to 50 meters per second, and this first body is 6 kg. So this is simply applying our principle, which is Ft equals to mv minus mu. Do you remember? We said that impulse, whenever force and time is not given, we can say impulse is equals to, notice sometimes what the problem students have is that they will start checking, there's no force, there's no time, how come? Or they'll start looking for how to, just remember that Ft is impulse. change in momentum is impulse. So this is going to be 6 times the final velocity is 15, then minus 6 times 20. Or you can as well do 6 into 50 minus 20, which gives you 6 into 30. Yeah? So that when you do this thing, you see that you have around should be around 180. Yes, you have around 180. So 180, and this is going to be, the impulse is going to be in Newton seconds. Yes, so we are correct. So let's move to the next question. Next question says 8 kg block, an 8 kg block is at rest. 8 kg mass is at rest. It means initial velocity is 0 at time t equals to 0. That is from the beginning. Anytime you are doing something from the beginning, time is always 0. So a constant force F acts on the block along x-axis, no problem. Constant force, okay. At t equals to 2 seconds, that is, it acts on the block along x-axis. I don't know force. The block has moved 4 meters. So the block moves a distance. Pay attention to when they give you meter. Is distance or displacement, not velocity. So 4 meters, distance or displacement. Distance and displacement, they are the same thing, just that displacement has direction, distance does not have direction. It simply means position, or should I say change in position, or you say average position. So they're asking us to find F. Look at what, and they gave us time. The only time given to us there is 2 seconds. That's time for beginning, does not matter. So what this thing means is simple. Let's look at it. I know that displacement, first of all, velocity is given by displacement over time. So this is going to be 4 over 2 equals to 2 meters per second. There are some questions I see, I don't even know what to solve, but I just start looking at what I'm given. Then start thinking of the elder brother of that thing that I'm given to see what I can get from it. So I've gotten V, that is velocity. Okay, and remember that it's at time 2 seconds, that is letter. The time for this initial is 0. So that means that you remember that F is equals to MA. But there's no MA given to me here. But I can simply remember that F is also equals to MV minus MU. Is it not true? Yes. So I can simply have M to be equals to 8, then V is 2 minus 0. Should be? Let us check. Should be 4 divided by 2. Yes. So this is going to be 8 times 2, which is equals to, if you remember, this thing is equals to the same thing as saying M into V minus U. So this is going to be the same thing as saying 16 Newton. So you can see this thing also being solved this way. But what I like to do is whenever I see force, I try to use anything that relates to force that I know. If it can't work before I start looking for kinematics equation. In some textbooks, you see this thing, they will start using kinematics equation to solve it. It's okay. But I want you to always take it that whenever force is mentioned, first look at how possible it is to use the 3 laws of forces to solve. If it's not possible, before you look at kinematics. Remember I told you that kinematics deals with laws of motion. Dynamics deals with laws of motion. Dynamics deals with laws of motion. Laws of motion. While kinematics deals with equations of motion. So when I'm giving a question and I see force, automatically that question relates more to dynamics. In kinematics, we don't pay attention to the force. So I like to see if there's any way I can use all the formulas or laws of dynamics to solve. So that is what I did here. But you see some textbook will come and tell you, since they mention displacement, half s equals to ut plus half at square. Yes. And a is not given, but let's see what we can do there. We have s here is 4. Then u is 0 times t, it becomes 0. Everything here will cancel. Now, half a, we don't know. But t, they gave us t to be 2 seconds. So raised to power 2. You can see that this becomes half of 2 raised to power 2 is 4. So it becomes half 4a equals to 4. And you know that this can go and times this, so that you get 4 times 2 is going to be 8 equals to 4a. So that you now have divide both sides. You see stress. This thing is stress. Then you have 4 here, 1. Then you have here 2. Yes, you have 2. So a is equals to 2. Then you now go back and say, but the MO you are given is equals to 8, shebi? So F is equals to MA. So that you now come and see you do 8 times 2 equals to 16 Newton. Whichever way you use it, you will still get the same answer. But I like to first of all look at what I can do with equations of dynamics. I think of dynamics as simply all about force. Think of kinematics all about motion. That definition where they give you the study of motion with respect to force and study of motion without respect to force is confusing to some students that don't understand. So anything motion relates to kinematics. When it has to do with force, I look at the forces. When it has to do with dynamics, I pay attention to the forces before any other thing about motion that enters it, and I see if I can work it with kinematics. All right, let's move to the next question, question 9. So they say a particle of mass 0.4 kg is subjected to 2 forces. Let me just be writing as I'm reading. Mass 0.4 kg to 2 forces, F1 2I minus 4G, F2 minus 2.6I plus 5G. In Newton, all in Newton. They now say if the particle starts from rest, once you hear from rest, u is equals to 0, initial velocity is 0. Whatever time they give you at 0 does not matter, overlook it. Find its position. When you hear position, they are talking about find its displacement, or they are telling you find its distance, the same thing. And velocity. At time, 1.6 seconds. All these things are very simple. Very simple, but when you are in year 1 like this, it will look as if it's hard. Very, very simple. All right. So what this thing means is simply they have given me vectors. They've given me vectors. That's what they've given me. They gave me vector here, gave me vector here. And we know that the way to look at vector, to add or subtract vector at the end of the day is to first resolve each one. I means x. Resolve y, j is for y. When you finish it, to add up or to subtract so that you get the resultant, you simply do Pythagoras. Remember, we did that on vectors. So since they did not say that the forces are in opposite direction, it simply means that I will get the resultant force. So let me do my I. This is going to be simply 2I, the first one, minus 2.6. That is, it's the same thing as saying F1 plus F2 to get my total force. That is what I'm going to do. So I'll get force on I axis and force on J axis. So for I axis, so for I, which is X axis, I will have 2I plus minus 2.6I. So that should give me 0.6. 2 minus 2.6, 0.6. And notice that it's carrying minus, so minus 0.6I. Then for J, which is Y axis, I'll simply do minus 4 plus 5. Yes, and this is the same thing as saying 5 minus 4, which is going to be 1J. Yes, and is in Newton. And now to add I and J to find the resultant is the same thing as saying I now have 1J, or you say J, then I have minus 0.6I to get the resultant. Will simply be the same thing as saying R, and is in Newton. So R will be the same thing as saying R square equals to 1 square plus minus 0.6 square. This is going to give me R is equals to root 1 square is 1. Okay, let me just put it plus minus 0.6 square. Minus 0.6 square. And whenever you take a negative number and square it, it becomes positive. So 0.6 times 0.6 gives me 0.36. Plus 1 square, anything raised to power 1 raised to power anything is 1. So remember why I put square roots, because I take the square root of both sides. This one will cancel. Guys, go and check my video on Pythagoras, on cosine angle and sine angle, everything vectors. Check my video on vectors. So 1 plus, this should be 1.36. Let's do it. 1 plus 0.36 gives me root 1. This is 1 point root 1.36 R. So let's do the roots. So root of 1.36 gives me invariably 1, but let's just write it the way we have it. R equals to 1.1661, and this means that R is approximately 1.2 Newton. Are you seeing it? It means that R is approximately 1.2 Newton. But I want us to look at something. Let's try to look at something here. At this junction, where I have to find, they said I should find its position, and I should find the velocity t equals to 1.6. Okay, to find its position, first of all, before we do this, if I'm to find the position, notice that I've gotten I to be 0. First of all, displacement is equals to, first v, velocity is equals to s over t. Should be? Yes. And which means that to get the velocity, there is no, I don't know the velocity, I don't know the displacement. And displacement is equals to, okay, yes, but wait, so let's check what we're given. We're given force. So let's analyze and see if there's any way we can. Yeah. So what we are given, we've been able to find, resultant force. We're able to find resultant force But let's try to look at this. I know that each of these, watch, let me do this here. Force on x-axis. Remember, this is resultant force. Resultant force means by the time you sum up everything. So let's do force on x-axis is equals to, we got minus 0.6. I. And remember that force is equals to MA. Yes. So if force is equals to MA, it simply means that force on x-axis should be equals to MEX. Let's find the acceleration on the x-axis. The mass can be the same thing. Yes. So the mass on the x-axis is what we want to find. Then we'll still find the mass on the y-axis. Also, the acceleration on the x-axis. So if we're considering mass is the same mass, so this is going to be the same thing as saying F here equals to MA divided by, what are we dividing? To get A is what we are looking for, by M divided by M. So this is going to cancel this so that I have A is equals to, that is acceleration on x-axis is going to be the same thing as equals to 0.6 minus 0.6 all over. The mass given to us in that question is 0.4. So 0.4. At 0.4. Yes. .4. So let's punch. Let's see what we have. I have 0.6 divided by 0.4. I have 1.5. So acceleration on x-axis is 1.5. Now, remember. So we did remember here. So remember again. Force on y-axis, which is j-axis, is the same thing as saying F on y-axis is equals to 1g, or you say 1 Newton, is equals to 1 g. Which is the same thing as j. So which means that A on y-axis will be equals to Fy over m, which is the same thing as saying Ey is equals to 1 all over the mass, which is 0.4, is the same mass. (2.5 meter per second square). Okay, so we've gotten the acceleration on both sides. But remember, they asked us to find velocity. And we know that, okay, don't want to confuse you. Now, so let me do this here. Okay, we know that velocity, first of all, acceleration is equals to velocity over time. Best. Which means that velocity can be the same thing as saying product of acceleration and time. So velocity on x-axis will be equals to ax times time. And the time given that they are asking us to find this thing, they said after 1.6 seconds. So 1.6. So Vx is equals to 1.5 times 1.6, which accounts for 1.5 times 1.6, 2.4. We are getting acceleration to be velocity to be so we're getting velocity on the x-axis to be 2.4 meters per second. So while on the y-axis, Vy will be equals to Ay times 1.6. So Vy will simply be the same thing as saying 2.5 times 1.6. 2.5 times 1.6. Vy is equals to 4. Is equals to 4 meters per second. So remember they asked us to find the position as well, which is S displacement. So to find the displacement, so we've gotten the velocity at x-axis and y-axis. So now to find the displacement on both axes, it's going to be Sx equals to, we know that V, velocity is equals to displacement over time. Displacement, on the other hand, is equals to product of velocity times time. So this is going to be Sx is equals to Vx times t. So Vx is equals to 2.4 times 1.6. So 2.4 times 1.6 is equals to 3.84. So Sy is equals to Vy times t, which is 4 times 1.6. And this is going to be meter. Okay. So this is our answer for the position. So for the position is going to be simply 3.84 I, 6.4 J meter. Then for the velocity, that is S is equals to the displacement. Then the V, the velocity is going to be the same thing as saying 2. We normally write the x-axis first. 2.4, 4 meter per second, Ig. Then the acceleration, A, is equals to 1.5 I, 2.5 J meter per second square. Then the forces, okay, we already know the forces. The force is F is equals to minus 0.6. Okay, yes. This minus is supposed to be here. Minus, thank God. Minus 0.6, then 1 Newton. So let's check our answers. So we have for force on the x-axis, acceleration on the x-axis is supposed to be minus 1.5 at the end of the day, because this is minus 0.6. Minus 1.5. Then where I have the velocity on the x-axis is supposed to be minus 2.4. minus 2.4. And where I have the displacement on the x-axis, supposed to be minus 3.84. So minus 3.84 minus, yes, everything x has minus. Everything on the x-axis has minus, like in this question. All right, so there you have it. But remember that we went on to find our resultant force. And our resultant force is 1.2 Newton. So as I have this resultant force, if I want to check everything that happens on the system, that is the displacement and on the velocity, I can still do it using this. But this time around, I will no longer have I and J parts. I'll simply have everything to be together. So whichever way you do it. But I will advise you, when a question is given to you in I and J, make sure that, see what I mean? When a question is given to you, when you are given to find velocity, displacement, or whatever, or acceleration, and you are given the force to be I, J, or K vector, in I, J, K vector. So the best way to do it is to simply solve for the velocities, displacement, solve it individually, displacement and acceleration on I, J, K. So do it as a vector. Solve it as a vector, or a vector question. See it as a vector question. So that's how you go about it. All right. So let's move to the next one.